In this lesson, we're going to discuss SQL and XML injection attacks. Now, an injection attack occurs when an attacker sends malicious data to a system, which is then processed as part of a command or query, which can lead to unintended consequences. Now, regardless of whether the attacker is trying to conduct an SQL injection or an XML injection, the concept and the goal of the attack is similar: to send some kind of code into our systems so that that attacker can perform some kind of malicious action. So let's go ahead and cover an SQL injection first, and we'll talk a little bit about the background of SQL so you can understand how it works. Now, when you're dealing with a database, you have to have a way to talk to that database in order to read, write, or search for data inside of it. Now, this is done by using statements in a language known as the Structured Query Language, or SQL. Now, there are four main actions inside of SQL that you can use to manipulate the data held inside of a database. These are select, insert, delete, and update. Now, to select something means that we want to read that data from the database. To insert something means that we want to write data into the database. To delete something means we want to remove that data from the database. And to update something means I want to overwrite that data in the database with a newer version. Now, let's take a quick look at how SQL works in the real world. When you try to log into a website, you may encounter a basic login form asking for your username and password. Let's pretend I enter Jason as my username and pass123 as my password, and then I click Login. Next, the website is going to send my username and password over to the database and make a query to determine if my username and password match what is being stored inside of the database. To do this, it's going to use an SQL statement. For example, I might have the statement of select star from users where user ID equals Jason and password equals pass123. Now, this information goes into the database, and then we'll determine if there is a perfect match. If there is a match, we're going to have access granted, and everything is going to be wonderful. That is a very basic and major oversimplification of how SQL works, but at least it gives you a good idea. Now, if you're a database engineer, I know I really made that much simpler than it really is, but this is the baseline knowledge that everybody watching this video needs to have before we can move forward and talk about an SQL injection. So please don't send me a bunch of hate mail over my oversimplification. I'm just trying to make it easier for everyone to understand. All right, now let's go ahead and move into the code injection portion. Now, a code injection is the insertion of additional information or code through a data input form from a client to an application. Code injection is a generic form, but what we're going to be focused on specifically right now is an SQL injection, which is a specific type of code injection. This is how a lot of attackers are going to insert malicious SQL statements into our applications and cause havoc for us, so it's important to understand. Now, an SQL injection attack is going to consist of an injection of an SQL query through the input form that a client is going to use to send data over to a web application. When conducting an SQL injection, the attacker is going to try to insert parameters or code into the SQL statement that's going to be used to query that database. To do this, the attacker can either inject their input as a URL parameter by entering the data into a form field, by modifying cookies, by changing post data, or by using an HTTP header to find an SQL injection vulnerability. Now, while this sounds like a lot of work, it's actually pretty easy to automate this process as an attacker because there's a lot of great tools out there that focus on SQL injections and exploits. So, as a defender, it's going to be our job to protect our databases from these SQL injections. And to do that, we have to understand how these SQL injections are actually going to work. Now, let's go back to our example of logging into a website and see how the SQL injection could exploit our site. First, we have the login form that's used by the clients to enter their username and password. As an attacker, I'm going to put that in as my username that I want to log in as, and in this case, that's Jason. Then I'm going to insert the password. But as an attacker, they don't know what Jason's password is. Now, you all do because I already told you it was pass123, but as the attacker, what I'm going to do is I'm going to add an apostrophe and type or 1 equals 1 semicolon. Now, that looks pretty weird, right? Well, it does, but the reason that I'm doing this is because when I put that in and I click the login button, that data from the form is going to be inserted back into the SQL statement on the back end and then queried to the database. Now, what we have just done is we are going to use that command select star from users where user ID equals the user we entered, which was Jason, and password equals, and then what we entered for our password, which in this case was apostrophe or 1 equals 1 semicolon. Now, notice when I sent that to the system, what I'm seeing there is that access is granted. Now, why is that? It's not because I got the right password. The reason is because I just performed an SQL injection. What ends up happening when you have something like this apostrophe is that it serves as an escape character. So what I really was injecting into the SQL statement was for the system to evaluate whether what I entered as the password was a match for the password for Jason or does 1 equal 1. Now, let me ask you a quick question here. Does 1 equal 1? Well, yes, 1 equals 1. Every single day, 1 is going to equal 1. It's a true statement. So anytime we run this command, we're going to get a true statement because we're checking if password or 1 equals 1 is true. And in this case, 1 equals 1 is always going to be true. So based on simple Boolean logic, even if the password was wrong, because I put it blank in this case, I'm still going to be able to get into the system because I have 1 equals 1 as a true condition. And anytime you're using Boolean logic, if one of the conditions is true, the entire statement is true when you're using an OR statement. This is why I'm going to get an access granted. I'm going to be able to log into the system as Jason, even though I didn't have his password. This is why SQL injections work when people are trying to break into a database, because they are forcing a true condition to occur. Now, this is why preventing an SQL injection from being able to occur is really important. And the best way to prevent an SQL injection is to use something known as input validation and to sanitize any data you receive from your users. Now, for the exam, anytime you see something with an apostrophe and something that equals something, I want you to automatically think this is probably an SQL injection attempt. Almost every single time, that's going to be the right answer. Now, be aware, anytime you see in the log something that is something equals something, it doesn't always have to be 1 equals 1. It can be 7 equals 7 or 15 equals 15 or whatever. As long as that statement will always evaluate to true, it is a form of SQL injection. I guarantee on the exam, you're going to get at least 1 or 2 questions about SQL injections, and they'll either be focused on you being able to identify that it was an SQL injection by seeing that 1 equals 1 or something similar like that, or they're going to ask you how to prevent an SQL injection. And if you're asked to prevent an SQL injection, what is the right answer? It is input validation. So remember that. If you can validate or sanitize the input, you're going to be able to prevent an SQL injection from occurring because you can filter out those apostrophes or something equals something and not send that to the database. Now, another great way to prevent an SQL injection is to simply use a web application firewall and placing it between the client and the web server, because the web application firewall will be able to perform that input sanitization and input validation for you, even if you can't rewrite the application's code itself. Now, on the exam, if you have a question that's asking about attacks against a database, almost always the answer is going to be an SQL injection. Why? Because databases use SQL as the way to read and write information from a database. So again, keep these tricks in mind for exam day, and I'm sure they're going to come in handy for you. All right, now that we've covered SQL injections, let's move into our coverage of XML injections next. Now, XML stands for the Extensible Markup Language, and it's used by web applications for authentication, authorization, or other types of data exchange. XML data is submitted from the client to the server or from one server to another. To protect XML data in transit, it should always be sent inside of an encrypted tunnel, such as by using a TLS tunnel. To protect your server when it receives XML data, you should always conduct input validation and input sanitization of the data before you process it. This will protect the server from any kind of XML exploitation or injection attack that the attacker is trying to perform. If you submit XML data without encryption or without input validation, it's going to be vulnerable to snooping, spoofing, request forgery, and injection of arbitrary code, so you want to make sure you're doing encryption and input validation anytime you're sending data in XML format. Now, when you look at XML data, it's going to appear to be in a human-readable format as a series of tagged fields. Now, here's a short XML file that I created containing a practice exam question. The first line defines the text file as an XML file and defines what version of XML and the type of encoding I want to use. The second line is going to define the type of data I'm using in this XML file. In this case, I'm defining the information contained as a question for a web application quiz program that I'm writing. Next, you're going to see there are 4 more fields inside this question type. The first field is the ID field, and you'll see here it contains a unique identifier for this sample question with a label of security-002-0001. Next, I have a title field, and I titled this question as, "Is this an XML vulnerability?" Next, I have choice 1 and choice 2 as fields. Now, the great thing about XML is that it can be configured with whatever fields you want based on your specific application that you're building. In my case, I'm showing you how I would define my questions for this quiz application. Finally, you'll see we have the /question and the /XML tags to close out this data, just like closing out an HTML tag in a website's code. Now, if you see something like this on test day, you should be able to identify it as XML data. In this example, there is nothing malicious. It's just regular XML data that's being used to contain information and send it to or from a given application. In this case, it's a quiz application that I'm building. Now, there are some exploits that you're going to come across with XML, and so let's talk about a couple of those. First, we have an XML bomb. Now, an XML bomb is also known as a billion laughs attack. Now, an XML bomb takes an XML file and then uses encoding to encode entities and expand them into exponential sizes, which will consume memory on the host and potentially crash it. The reason this is called a billion laughs attack is that the XML entities referenced in this file are written as LOL1 through LOL9. Each of these references the line before it, so starting at the bottom with LOL9, you can see we have 10 LOL8s, and in LOL8 there are 10 LOL7s, and this pattern continues all the way up, and essentially it creates a billion LOLs because of this factorial nature of the entity references that's being used. Now this simple code can actually consume up to 3 gigabytes of memory due to the repetitive references that are being made inside this XML file. So if an attacker is able to get to your server and have it process this XML file, it can then start consuming all of these resources on your web server, and this is why we call it an XML bomb, because it acts like a bomb or denial of service attack. Now the second type we have is what's known as an XML external entity or XXE attack. This type of attack attempts to embed a request for a local resource. Now this sounds a lot like a local file inclusion, doesn't it? And here's an example of an XML external entity attack. Again, notice we have the XML version and the encoding in the first line. Next, we have a document type listed as foo, which is just code or speak for some kind of a junk variable. Then we have an element foo any, and we have the entity XXE system, and then the file //etsy/shadow. And then we end this out with some kind of data inside of XML format. In this case, we're calling that foo as well. Now, most of this doesn't look too bad or malicious, but that fourth line that contains the /etsy/shadow file is because this XML entity is trying to read the shadow file of a Linux machine, which contains the password hashes for that system's accounts. Now, to prevent XML vulnerabilities from being exploited, remember, you need to use proper input validation. Input validation, input validation, input validation. I keep mentioning it for our different web applications and exploits because it really is that important. Anytime you're getting input from a user, whether it's a URL being inputted, a file being inputted, a field being entered on a website, or some kind of XML data being sent over, we can prevent a lot of security issues if we just use input validation. Now, for the exam, if you see something with XML written in it, and it is clearly XML, guess what? That's most likely going to be an XML vulnerability that's being exploited. They might call this an XML vulnerability, an XML exploitation, or an XML injection. Whatever term they use, it really doesn't matter. It really is just XML being exploited when you see XML formatted data in a question on the exam. Now, the only real tricky part with an XML code is that it often can look like HTML code or JavaScript. To tell the difference, remember that HTML or JavaScript uses defined keywords for each of those bracketed entries. But with XML, you can make those say whatever you want depending on how you configure your XML file. So on the exam, I want you to take a moment anytime you see a piece of code and look at it and then determine, is it HTML, is it JavaScript, or is it XML? If you see something like a font or an image or an href in the tag, that is going to be HTML. If you see something like question or ID or type or element or entity, that's going to be XML. If you can make this kind of determination, you're going to have no issues answering questions that involve XML vulnerabilities, exploitations, or injections on the exam. So remember, an injection occurs when an attacker sends malicious data to a system, and it's then going to be processed as part of a command or query that can lead to unintended consequences. An SQL injection is an attack technique where malicious SQL code is inserted into input fields to manipulate or exploit a database-driven application. If you see something like '1 = 1, this is going to be an SQL injection. XML injections, on the other hand, is an attack technique where malicious XML code is going to be inserted into input fields to manipulate or exploit an XML-driven application or service. If you see any code that appears to be written in XML format in a log snippet on the exam, you can take a safe guess that this is an XML injection that's being attempted by an attacker.